In this problem, we want to take the integral of this algebraic term x squared minus 3x plus 1 multiplied by exponential function e to the power of 2x. Because these two functions are totally different from each other, the nature of them are totally different. One of them is algebraic, is a polynomial, and the other one is exponential function. We may think about some methods like u substitution, which it doesn't work here because we cannot find the specific u here, which is helpful. And or the other good method for this type of questions is integration by parts. And for applying integration by parts, which let me just write the equation for that, integral of u dv is equal to u times v minus the integral of v du. And here, this is the integral that we have, and we want to convert it into a simpler integrals. And that's what we are hoping for. But to start this method, we need to decide which part is u and which part is dv. And to see which part is u, it's the best kind of, if we don't have any clue that where to start off, we can use this mnemonic for the order of functions in integration by parts, which is I late. You can memorize that simply. I stands for trig inverse, or kind of I can say inverse of trig. L stands for logarithmic function. A stands for algebraic function. E stands for trig function, and E stands for exponential function. So based on what we have here, we choose which part should be u. So here what we have is a polynomial which is algebraic, so it's the a part, and we also have e to the power of 2x, which is an exponential function, which is this one. But because a is coming before e, the a part, the algebraic terms, would be our u. So this would be the u, and the rest of that would be the dv part. Now that we have it, we can kind of start to construct the right hand side. But to write the right hand side, we need to have v, which is the integral of dv, and we need to have du, which is the derivative of the u. So let's just write them here. We said u is x squared minus 3x plus 1, and dv is equal to e to the power of 2x dx. So from here, we can find out what du is, which is just simply we take the derivative of that, which is 2x minus 3 dx. Let's make sure that the entire thing is times dx. And to find v, we simply take the integral of that function. v is equal to integral of e to the power of 2x is e to the power of 2x over 2. Now that we have it, by the way, if you have any problem with taking this integral, you can simply use u substitution. So now the integral that we have, which is x squared minus 3x plus 1 multiplied by e to the power of 2x dx, it can be written as u times v, which is basically this times this, x squared x plus 1 multiplied by e to the power of 2x over 2 minus, because of that minus that we have here, integral of v du. v is e to the 2x over 2, and du, which is this part, 2x minus 3 times dx. 2x minus 3 times. So this is another integral that we have right now, which kind of is not, again, very simple to be taken, but it's definitely simpler than what we started with. Here we had a second order polynomial quadratic function, but here it was kind of reduced to a linear function. So it seems it's getting a better or a little bit easier integral. So let's take care of this integral now separately, and then we write the whole thing. To take this integral, again, we have a similar scenario that we have exponential function and we have algebraic function. They are multiplied by each other. Again, u substitution doesn't work that well here. So the best method here would be integration by parts. So again, if we go to this mnemonic, we can see that, okay, we have exponential function, or you can just choose the whole part as exponential function, or you could just take out these two and then deal with the integral. I just leave it as is. So we have this exponential function, and we have this part which is algebraic. Again, algebraic is coming before exponential in this isolate mnemonic. So algebraic part would be the u that we have. So the u that we are gonna use in this part is 2x minus 3. And the dv would be basically the rest of the terms, which is e to the power of 2x over 2 dx. I mean, this part and this part together becomes the dv. So from here, we still need du. Again, just this u and dv is not a u substitution. It's just names that we use to be able to complete this integration by parts formula. So that's why the u here and the u here are totally different things, and it's not confusing. It's different from u substitution. Okay, du is equal to the derivative of this, which is 2 and dx at the end, and v here is basically the integral of dv, and the integral of e to the power of 2x over 2 is basically e to the power of 2x over 4. Every time we take the integral of e to the power of 2x, it would be e to the power of 2x over 2. So we already had 1, 2, and another 2 comes out. It becomes over 4. Now again, we can write this integral, take that integral by integration by part. So let me just focus on this part for now. So here, what I have is integral of e to the power of 2x over 2 times 2x minus 3 dx. I can write it as uv, which is these two multiplied by each other, e to the power of 2x over 4 multiplied by 2x minus 3 minus the integral of v du, which is e to the power of 2x over 4 multiplied by 2 dx. Now we have, again, simpler integral. This is actually integral that we already know. So let me just take this integral now separately. So we have 2 and 4, they are constants. I can just take them out. I have 2 and 4 out. And the integral of e to the power of 2x is e to the power of 2x over 2. Now these 2 and these 2 cancels each other. So we have e to the power of 2x over 4. So overall, this integral is, let me just write that again, e to the power of 2x over 2, 2x times 2x minus 3 dx is this part, which is e to the power of 2x over 4 times 2x minus 3, minus this integral, which is basically e to the power of 2x over 4. Let me move this a little bit to the left so it's confusing. So this is the answer to this integral, which was part of the previous integral, previous integration by parts formula. So the final answer that what we are looking for is this integral. Let me just copy this. So this is equal to the first part that we had, this part. Let me just also copy this. minus this integral, which we took it separately down here, and this was the answer. Just make sure that when I'm just copy pasting these, I have a bracket around it, because it's very important, especially because of this negative sign. So I have a bracket around these. So overall, what is the final answer? Again, I just write it as x squared minus 3x plus 1 times e to the power of 2x over 2 minus e to the power of 2x over 4 times 2x minus 3. And this minus together becomes plus sign, plus e to the power of 2x over 4. I can take out e to the power of 2x, e to the power of 2x. So what I'm left with here is x squared minus 3x plus 1 over 2, because of these two, minus, if I take out e to the power of 2x out here, I would get 2x minus 3 over 4. And if I take it out from here, I'm left with 1 over 4. Still, we can simplify that. We can write it as a one fraction, but it's really not necessary. So this would be the integral of this function. And because it's indefinite integral, again, don't forget that we have a plus c at the end. So to take this integral, we applied integration by parts twice, and the main reason that we needed to apply that twice was the order was 2. So we can somehow expect that if it was order 3 polynomial, it would need the integration by parts. It's not a general rule, but usually it happens.